Welcome to a new test and teardown video. Another power supply. This one is from Oltronix, Stockholm, Sweden. Type number is LS524R. It is tube based, so it's 1960, and it's looking really beautiful of its age. Definitely nice design and in a very good shape. It is a 2000 volts 10 milliamp supply, so that is 20 watts of output, and it's been modified a little bit. So there is a connector here in the front, and I don't know if this is output or a sense voltage, and we can select between positive or negative, or the output can be on and off, and of course we can adjust the voltage here. The meter we can change between voltage or current, and we can also limit we got two different ranges for the output voltage, so that looks more or less pretty good. Let's look a little bit on the rear side. So first we see this really big and ugly mains power connector. I think with a little bit of luck I can find a mating connector for that one, so I should be more or less fine for that. And that is of course the high voltage output. That is made real pro. Look how deep it is, and the isolation distances and all that kind of stuff. And so what the heck is this BNC doing in the front? And that is a very big mains power supply in relation to the 20 watts output. So we are inside this high voltage power supply, and it's like 90% air. It could have been a lot more compact, definitely, but they wanted it to be in this 19-inch case, so that's just how it is, right? So the first thing you see here is of course 3EL34 power pentodes. They are very well known from audio amplifiers. I also got 3 voltage regulator tubes and 3 tiny neon bulbs. You see? They're difficult to see from this angle. We got some output capacitors and the voltage set point pot meter. I don't know what that pot is doing. I didn't power anything up yet, so I know I can touch everything and it should be fairly safe. Main input transformer is really big and beefy. That's quite a few hundred watts easily, right? And then we got a rectifier, voltage divider resistor, and all the capacitors for all the... Oh, let me swing it around. So here we go. All those capacitors, they are more or less in series. I really need to inspect their state before I just crank up the power. What you see here, the high voltage is rectified, and then some more rectifier diodes. I think we got... Well, I don't know exactly what is going on here. That looks a little bit spooky with that, and then those, okay. Yeah, that is something I need to look a little bit more careful about. But what I think we got here, let me swing it and show you. The front BNC is not a normal BNC, but it's one of those high voltage BNCs, and it's made super deep as you can see here, with plenty of isolation. So you need a special BNC to connect to that one, by the way. The one switch here is the output enable disable, and the other one, look, those two are connected together. And also you see here the red one go down to the other one, and the blue one go down to that one. So this is the positive negative switch where you can change the polarity. And if I measure to chassis and to that point, it is truly reversed the output. So first I went to positive output, and this one is connected in parallel with the output connector here. So that's the same. As you can see, originally it was mounted with the same kind of big connector here in the front, right? So this one is connected to the other one. This one goes through this switch stuff, and then it goes up here. Let me swing you around here. See? This is the output. The positive output is here. The negative output is here when you are in negative output. When you are in positive output, that one is connected to chassis. When you go in negative output, that one is connected to chassis, and then that one is the output. So that is how it works. And that is because this entire high voltage supply is completely floating, isolated from chassis. So you can just connect one side or the other side to chassis, and then you get positive or negative output. Easy peasy. Now let's look at how we set the output voltage, because those tubes can't handle this kind of voltage. So what they have done here is they cascaded the 3 tubes, and that's also what they've done with the capacitors. So we got 3 sets of high voltage. 3 sets goes to 3 tubes in series. So I've written a little bit here. Maybe you can see this. I think it's difficult to show like that. So here we go. This is the bottom part of the 3 power pentodes, and that is the positive output that goes to the first tube's cathode. So this is just a cathode follower, and the anode of that one goes to the cathode of that one, and that cathode goes, and so on, right? So the 3 they're actually just in series, and that is how it works. It's a little bit funny the way that they made the grids, the way that they are connected with all those resistors here, doing a voltage divider from the voltage set pot meter. We also got some really nice resistors here, 1%, but then a temperature coefficient that is like 0.000 stuff. Those are connected with the voltage set pot meter, and that goes through some of these resistors, and then it goes to the different set points of the 3 output tubes. So before I can say it's safe to power this up, I need to power up the voltage real slow, and then verify the voltage on all the capacitors here is equally divided, because if that is not the case, I'm going to blow up some of the capacitors. So here are the voltages on the 6 capacitors. I try to crank up the input voltage slowly, 60 volts and then 120, and then I recorded the 6 voltages on those 6 capacitors. And I actually also see light in the voltage regulators, and I see filament, and I also get a lot of output voltage. So I think it is more or less working, but I'm a little bit worried about the voltage on some of the capacitors. As you can see, this is about half of the input voltage, and they are rated 500 volts each. So some are very high and some are a little bit low. They don't really share the voltage correctly. So that is something I need to monitor a little bit. I want to set I was going to find the highest, and then I will set a separate voltmeter on that one. There's actually also another thing that I found. If you see this point here, this is touching the plastic and it's also digging its way through the plastic. That can't be good, especially not if the diodes gets warm. I don't know, I don't like that. So I think I will try and see if I can move the capacitors a little bit to the right. That will be the AC input from the transformer. And then you see the AC goes through 3 diodes and become positive, and then it goes through 3 diodes and it becomes the negative, going all the way over here to the most negative. The fun thing is the way that they routed those capacitors. They connected them in series and all that kind of stuff, like that. So you see, this one goes in series with that one, in series with that one, and oop, now there's a wire from that negative to that positive, and then this one goes to the rectifiers. That's a little bit funny. Doesn't really look beautiful, huh? And here's the low voltage auxiliary power for some of the more simple stuff. So yeah, I'm still poking around with the power up on this unit, and I'm super skeptic and a little bit afraid, because it is potentially a lot of energy stored in all those capacitors, and I don't understand why they're supposed to be this big. 32 microfarads, 500 volts, and 6 of those in series. You can imagine this is a nasty one. Maybe I'm getting old and too careful about stuff, but it is up and running, and that will be the 500 volts on that capacitor. So I got 180 volts of mains input, and I'm just carefully monitoring this one and just slowly cranking up the mains input. As long as I don't have any more than 500 on that capacitor, I should be perfectly fine, right? So this is the output, 1000 volts, because the meter is in 2000 volt. And let me show you what happens here. See, if I crank up the output voltage, so yeah, it seems like I got some sort of regulation, but if I crank this all the way down, see, I'm not going any more down than that. That is weird, isn't it? Shouldn't it go to 0? And when you're playing around with stuff like this, you can't really touch anything or just measuring around inside stuff. It is really... Can you hear this? This is not good. I'll take my thermal camera and I will take a look. So those pentodes, they should be equally warm, right? But that is definitely not the case. One is very warm and the others are not. So that is weird. And also I can measure what's going on with capacitors, with the diodes, and with the voltage divider resistors down here. As you see, they are not equally warm, and that is a problem. That will be the diode voltage division here. Whew. Yeah, I knew that. So yes, this is definitely not working the way it is. So I have to turn it off. So here's what I did. I swapped those two tubes and now I'm powering up again and I see exactly the same behavior. I can still only variable the voltage from from 1000 and up. And now I will of course see if you see what I'm saying here. It is again the tube to the most left that is much more warm, and I just turned this on. So there's definitely something in this construction where I need to figure out what is going on, and it seems like it's not the tubes that's defect, so that is lovely. So while I am testing around, I figured out the 3 voltage reference tubes we got right here. I marked them so that I can't screw this up again, right? So that will be the reference tubes and the EL34. I also marked them how they were originally, and that is of course the numbers of the sockets, and I swapped those two, remember, and then still this one that gets much warmer. And I still got this problem with my minimum is 1000 volts, not 0 volts. So the voltage reference tubes, they're not exactly the same, all 3 of them, when you look at the numbers. So those are called SR5, and if I look them up, it says 85 volts and 1 to 10 milliamps. And if I look up the other one, it's called 85A2. It's almost the same voltage and almost the same current, and it even says that it's normally replaceable. So when one of them was replaced one time back in 19 something, right? I mean, maybe the others are defect too, so I want to test that they are working, of course, but also I want to verify the voltage that I got, the 1000 on this meter. Is that really 1000? So I'm gonna boot it up once again to verify that is indeed the case, because it's really nice and convenient to know this is accurate and correct, and then I don't need all this extra measurements and stuff and can just carry on from here, because I need to measure other things at the same time. Yes, output voltage is indeed correct. This is very close to 1000. And look at that meter, it's also very close to 1000. So I'm happy about that. And by the way, the power-up sequence of this unit definitely suffer a regulation problem because the meter hammers up. So maybe this is written in the manual. You need to have the output turned off when you power this up. I've seen this before on tube-based high voltage stuff. So just always be very careful about that. Oh, I just want to tell you, I am the dumbest there is. Of course I found the problem. Look, now we're only running on one of them. That one is running. And it's because now I am in the 200 to 1000 volt range. So that is the range this power supply can do. It's either 1000 to 700, 1750, right? Or 200 to 1000. It has never been from 0. So that is what this power supply is doing. So what the heck? Now I am in this range, and of course one tube is running. And look, it goes from about 200 and it goes all the way to 1000. Haha. So much for not reading the front. Here we go. And then there's nothing more. So that is what this thing will do. I am actually not too happy about that it don't go from 0 in one go and and if you are in this range, there is nothing less than 1,000, and that is potentially very, very dangerous. Seen from a user perspective, when you're doing something, you can't crank it up from 0. So, and I don't know if you can switch this while it is powered on. There is no warning on the front, but maybe it is written in the manual. I don't have the manual, so if anybody got the manual, please tell me, or please link, or please share the files, because I really want to know if I can switch this. The way that this is actually connected to capacitors, to tubes, and to the main transformer and all that kind of high voltage stuff. So as you see here, and it goes all that way, and it's doing a lot of stuff here. So I'm a little bit worried about switching this with power on. I don't recommend doing that. If you don't know, you can do that.